Morning, one and all. The continuation of the chemical bond itself to find out the hybridization as well as the shape of the molecule based on VSEPR theory. The first one, which we are going to do, the simplest way to find out when you are having two sigma bonds, it's going to be that's continuous going to be having sp hybridization. If it is having three sigma bonds, that's going to be what's called here. It's nothing but sp2 hybridization. Or it's going to be four sigma bonds, children. That's going to be sp3 hybridization. The shape which we are going to do later, but first of all we will finish this. In this four sigma bonds, we can do, that's the 4 sigma bonds. Or children, it's going to be 3 sigma bonds plus 1 lone pair of electrons. N stands for lone pair, N stands for sigma bonds. Also comes under sp3 hybridization. 2 sigma bonds plus 2 LPs also comes under what you call as here sp3 hybridization. But the children, the shape is going to be differs as the number of lone pairs changes. That shape is also going to be changed. For this, the beautiful example we know pretty well right from our basics are concerned. So this is one, and after that, Baba, here we are doing 5 sigma bonds. That's going to give us what's called here sp³d. That's going to be sp³d hybridization, or else 4 sigma plus 1 LP also gives same. And 3 sigma and 2 LP also gives same sp³d. And also we will go for, that's called whatever is called here 2 sigma and 3 lone pairs also comes under whatever is called here. Every example, we are going to have every example for each and every category is concerned. And coming to this, children, after this, we will go for what's called here. Another one is going to be, let's do this also. What's called, children? That's whatever is called here, N plus M gives rise to type of hybridization. It's going to be type of hybridization, Baba. Now, Baba, what's remained with us? It's you are having 6 sigma bonds. Followed? 6 sigma bonds means that's going to be having sp3d2 in general what we are doing, and 5 sigma 1 lone pair. 1 lone pair also predicts what's called here, it's 1 lone pair of electrons also stands the same, and 4 sigma whatever 2 lone pairs also stand. 3 sigma and 3 lone pairs also stands for sp3d2 hybridization. That's the utmost case. Finally, we will finish with that. As per our NEET and IIT syllabus is concerned, we will go for another one categorical example. 7 sigma bonds is going to be sp3d3 and 6 sigma and 1 lone pair, and that's going to give us the same hybridization, children. For that, every example are going to be discussed. 5 sigma, 2 LPs. No need, children, more than this also. Of course, in certain exceptions we are going to do. But this case is concerned. It's hybridization we have done in a shortest way based on sigma bonds as well as lone pair of electrons. But as per hybridization, we get only geometry. But when you go for this, as far as shape is concerned, it's merely based on number of lone pair of atoms on central atom. Let's do this, children. Every lone pair reduce the bond angle approximately 2.5 degrees. Followed? And that's which we are going to do. Regarding some examples we will take, children. That's very simple and possible example that which we are going to do. And the best example also, and sp3d. While we are going to this, we will do one more interesting thing. what type of orbitals involved in hybridization of what's called here sp³d, sp³d², and what's called here sp³d². Let me question you all. After that, we'll go for any different kind of examples, Baba here. Right, children? Listen. What's the d orbital or orbitals participated in hybridization? Participated in HYD, Hyderabad, or hybridization. Let's do this, Baba. Yeah. What's called here? For instance, I'll go for what's the d orbital is involved with sp³d. That's is going to be dz². It's going to be oriented along the axis. That's why it's going to be dz². And next one, if you are coming to that sp³d², it's going to be dz², dx². See, this is what we are going to do regarding the hybridization. That's nothing but what is said here. sp³d, sp³d², sp³d², which d orbitals will participate in the hybridization, whether it is dxy, dyz, dzx, or it's going to be dz² or dx²-y². And that's what we are going to do with respect to this. sp³d, because the z is going to be on the axis, that is going to be combined with sp³ hybrid orbitals. That's why dz² is participated preferably. And after that, these are also along the axis, as some people says dx² - y². So that dz², x²-y² also along the axis, and these two participate in this case. But coming to this, there are various cards, but it's going to be dz², dx²-y², and dxy is participated in hybridization. This is a very simple possible question. Though we learn pretty well, we can't answer this one so easily. That's what we are going to do with respect to hybridization is concerned. The d orbital which is participated in the hybridization is one of the possible questions, and it's given so many times in the many kind of examinations. Right, Baba? And with this, we'll go for shape also. Geometry as well as shape also. I'll write down a simple question. Suppose you are given that the question is going to be predict. I'm giving the question here. Predict the what's called here geometry as well as shape. Geometry and shape of the molecule. Here. How do you, Baba? Shape of the molecule, rather you can say species or ion or species, you can say Baba here. So this is what I am going to do. I'll start with this very simplest possible examples, but they don't consider them are worthless examples. For example, I'll go for PCl5. I'll go for what's called here SF4. I'll go for what's called here ClF3 and BCl5, SF4 and ClF3, and also that what I am taking xenon F2 also. See here. See, the tricky thing is that sp³. Sir, how do you find out its hybridization? Find out number of sigma bonds here. You will get what's called here the bonded atoms are 5. Its n value is going to be 5 sigma, 4 sigma plus 1 lone pair. It's going to be 1 lone pair. Can you remember this? Just now I have done in the previous classes. Just before I have done in the previous classes. 3 sigma and 2 LPs, lone pair of electrons. And it's going to be 2 sigma, whatever is called here, it's what's known as here, plus 3 LP of electrons. Right. Let's do this. I'm going to finish this example. See here, when there is no lone pair of examples, PCl5, I'll take children. Better, I'll go this side. See Baba here, cautiously observe this. It's a decent example for one and all. PCl5 is concerned, just I'll do with this. PCl5. How many hybrid orbitals are present? 5 sigma bonds. Its geometry is going to be, sp³d hybridization. Trigonal bipyramidal, TBP. Geometry is TBP. Shape is also same. It's ditto. Because there is no lone pairs of electrons. And this is regarding our PCl5. Let me go for SF4 children. TBP is going to be same because its hybridization is going to be sp³d. But the shape is going to be that it's called seesaw shape because it has one lone pair of electrons or at equatorial position in sp³d. The lone pairs preferably goes for equatorial positions but not axial. Why? Because equatorial has more electronegative character that we will discuss in other band school and all. And or at equilibrium position is concerned, equatorial position, right Baba? So that's what's going to be here. PCl5 is this. Second or third also we will take ClF3 is the example of ClF3. Geometry is trigonal bipyramidal Baba, but the shape is T, followed T shape as such, because it's having what's known as here 2 LPs are there. It's going to be having 2 lone pair of electrons at equatorial positions. Lost or least, we will find out. It's a beautiful example. That's xenon F2. Of course, you are all learned, but just the clarity will be to solve the questions as early as possible. It's going to be linear in shape because what's that? Because 3 LPs are at equatorial position. 3 LPs are at equatorial positions. Okay, this is what we have done. Yes, just for sake of idea, I am going to finish this, but with the giving diagrammatical representation. Geometry of PCl5 is concerned. It's trigonal bipyramidal. It's going to be trigonal bipyramidal. And whatever is second one is called here, it's what's known as here SF4. Its hybridization is same here. That's going to be one is at equatorial position. That's going to be SF4 seesaw shape. The another one is called ClF3. That's Baba here. We will take the central atom is going to be this. And 2 lone pairs are extended, mostly in sp³d. Not mostly, practically. They are extended to equatorial positions only. This is ClF3. Coming to that, xenon F2 Baba here. Are you able to see? Are you able to observe me here? Xenon F2, that's going to be here. This is related with this one. Okay, children? Right? This is the end of this session. We will continue part 4 in the next session. Not only with this, how to find out this fractional charge, average fractional charge, average bond order, and all those things, p-pi, d-pi concepts also. And after that, we will switch over to other concepts. Thank you very much.